Hi, welcome to Let's Calculate Something. Today we're going to do some calculus, we're going to do some differentiation, and we're going to use the chain rule. The chain rule is a very important differentiation technique, and it's used in a lot of places, and it's actually going to come into play when we get to integration. And so there's a couple different formats that you can write the chain rule in. This format says if you have a composite function of f and g in terms of x and you want to take the derivative of it, then the derivative is the derivative of the function in terms of g of x times the derivative of g of x. So you're going to see that play out when we do some examples. Then another format you could see is that if you have y, which is equal to u as a function of x, then the derivative of x with respect to y is going to be dx du times du dy. So these are two formats that you'll see in textbooks, that you'll see in examples. We're going to kind of stick to this one up here, but I wanted to show you both for clarity. So the way we're going to demonstrate this is we're going to go through three examples. The first few are first couple are pretty straightforward. The last one is going to use the product rule. So when we get to that, I'll show you a link where you could leverage the product rule and learn more about that. We had a whole video on it. So we'll start with the first one and we'll work through all three. And then I'm going to have a second video with more advanced techniques, much more complicated problems, three more, which we'll put up later. But I'll put a link I'll put a link up here so you can get to the advanced one if you like. Okay? Okay, so for our first example, we have f of x equals sine of x cubed. And sometimes with the chain rule, when you're first starting out, it's helpful to break down exactly what we're going to do in what order. So first thing we're going to do is we're going to differentiate this whole function. Okay? We're just going to treat this as if it was just regular x. Then we're going to come back through and we're going to differentiate that piece. Okay? So if we try that, if you do this, it makes it a lot easier to kind of see. So this is first, and this is second. Okay? So let's give it a try. So f prime of x is going to equal cosine of x cubed. Because again, we're going to kind of ignore what's inside here. Then we're going to take the derivative of the piece that we ignored, which is x cubed. So what is that going to equal? It's going to equal 3x squared cosine x cubed. And that's our answer. So we were able to differentiate this using the chain rule by breaking it up as the big piece times the little first. Break big piece first, and then what's inside second. So if that's a nested function, that's the nature of the chain rule, that's our answer. So now we'll go on to the second problem. For our second example, we're going to differentiate a function e to the 4x squared. So we'll start out by differentiating the first part, which will actually be just e to the 4x squared, because e, the derivative of e to anything, is itself. So we have 4x squared here times the derivative with respect to x of 4x squared, and that is going to evaluate to e to the 4x squared times 8x. So the answer is 8x e to the 4x squared. And that's number 2. Pretty straightforward. Pretty easy when you break it down like this. Very simple. Okay, so now we're going to solve the most complicated problem in this series. This is where we're going to need to deploy the product rule and the chain rule together. And before we get into solving it, this would be a really good time for you to click that subscribe button and then also click the notification bell so you can be alerted to when we create more content, and we're going to be creating a lot of content. Also, if you can click the like, if you like the video and you got value from it, please click the like. And then in the comments, give us some feedback. We'd love to hear from you, hear what you think about our videos, see if there's any changes you'd like to see us make. And then also, if you want to suggest a problem with differentiation, calculus, the chain rule, etc., we'll take a shot at solving it. And if we make a video of that problem, then we'll give you credit in that video. So without further ado, let's solve this problem. So we're going to deploy the product rule, and then we're going to deploy the chain rule. And the product rule says that when you have a function of y, which is the product of two functions, then the derivative of the function is going to equal the derivative of the first function times the second function plus the first function times the derivative of the second function. And we did a video on this product rule, and you can see the link up here. And if you click on that, you want some further explanation of the product rule, and you also want to see some examples of that, then that's the video you want to go to. Okay, so let's solve this problem now. And the first thing we have to do is define g of x and h of x. So g of x is going to equal x to the fourth, and then g prime of x will equal 4x cubed. Okay? And then h of x is going to equal sine of x cubed. Now I'm going to write it this way because it makes it a little easier to apply the chain rule. And so with the chain rule, it's always nice to see how you're going to unpack this nested function, if you will. And so here we're going to take the derivative of this piece, and we're going to kind of treat that like it's a variable. That's the first thing we're going to do. And then the second thing we're going to do is take the derivative of that piece, which is the internal part of the function. So we're going to do that second. Okay? So let's do it. So h prime of x will equal the derivative of this, which is 3 sine x squared plus times the derivative of this, which is sine x, which is cosine x. Okay, so now we have g of x, we have g prime of x, we have h of x, and we have h prime of x. So we can plug into this and find our derivative using both the chain rule, which we use to get h prime of x, and then also the product rule to get the whole thing. So f of x, f prime of x, will equal g prime of x, which is 4x cubed, times h of x, which is sine of x cubed, plus g of x, which is x to the fourth, h prime of x, which is 3 times sine of x squared cosine x. A little crowded there. So now we can factor some things out. So let's see if we can simplify this a little bit. Always good to simplify when we can. And we see that we have common here. We have the sine part of this is a common. We're going to factor that out because it's smaller, cubed, and this one is to the second power, and this is cubed. And then we have x cubed. We're going to factor that out of that. Okay, so let's just really write that pretty quick. So we have f prime of x equals x cubed times sine squared of x times whatever's left, 4 sine of x plus what's left here, x, 3x cosine x. And that's our answer. So we were able to use the product rule, which we defined here, and the chain rule, which we just learned, and we were able to solve a pretty complicated problem. Sometimes you can even have the quotient rule and the product rule and the chain rule all together, and we'll see some of those things in the big examples that we have, the more advanced examples that we are going to post very shortly. Okay? Thank you for watching, and we'll look forward to seeing you on the next video. Thank you.